There is said to be more microplastics in our seas than stars in our galaxy. It is estimated that about 8 million tons of plastic debris, such as food packaging and plastic bottles, are being washed into our oceans each year, where it is broken down into smaller microplastics that act as a magnet for chemical toxins. The particle sizes 1 to 3 millimeters constitute 62% of all marine plastic pieces. Even smaller sizes of microplastics under 20 micrometers in sediments have been reported. Microplastics can't be seen by the naked eye, so how can we manage a problem we don't fully know the extent of? Mid-November 2017, on Shelby Beach in southwest Victoria, where a sewage treatment plant didn't identify millions of nurdles travelling through their system, leaving them to be flushed out to sea, causing a Class 2 state of emergency to be put in place. Many locals rushed to aid the beach by conducting beach cleans, but months after the incident, nurdles are still being found.
Nurdles are impossible to contain, and once they've been released into the marine environment, they can be taken out to sea and float endlessly in the ocean's current.
Smaller plastics such as nurdles are particularly dangerous because animals like fish and seabirds can mistake the beads for food. When ingested, nurdles can obstruct an animal's digestive system, reducing food consumption. They also take up toxins from the environment, making them after a long-term period toxic to marine life.
It can take years for plastic to break down, meaning the effects could be long-term and difficult to manage.
Plastics are extremely diverse in terms of chemical composition, properties, possible applications, and are widely distributed in the society and the environment. In 2016, global production of plastics reached 335 million metric tons, with 60 million metric tons produced in Europe alone. China is one of the largest producers of plastics in the world, accounting for around 1/4 of the global production. It is estimated that there is over 300 species eating these microplastics. Effects from entanglement or ingestion of plastic waste include suffocation or blocking of the digestive tract, eventually causing death. It has been well documented for birds, turtles, and marine mammals. Studies of exposure to microplastics in amphipods, barnacles, and mussels have shown that these organisms ingest all microplastics. Further studies on the mussels showed that the microplastics were translocated from the gut into the circulatory system and were found in the hemocytes. The ability of plastics to absorb persistent organic pollutants may cause additional problems. If these pollutants are released when ingested by the organism, remains to be investigated. Marine plastics can also be vectors of transport of sessile alien invasive species and may cause damage to ecosystems. Several of the chemicals used to produce plastics are hazardous for human health and the environment. These and their degradation products may be released during the life cycle of a plastic product. The plastic polymers are not considered as toxic, but in plastic products there may be non-bound residual monomers, polymerization chemicals, degradation products, and additives which have toxic properties. Plastic remediation is extremely hard, as we can't simply just ban plastic. How can we fully tackle it when we don't fully understand the extent of what we're dealing with? It's hard to know the full extent of the problem. We can pick it all up, but that would be impossible. All we can really do is cut down plastic production and campaign for awareness.